Hi, my name is Oktay. Welcome to today's video about the chemical element chlorine. This is a picture of chlorine gas. It has a green-yellow color. Chlorine atomic number is 17. Name comes from chloros in Greek, which means green-yellow. And chlorine is a very reactive gas, and that's why it's in nature as chloride ions. And you can see there are three isotopes of chlorine. The two isotopes with even number of neutrons, chlorine 35 and 37, are stable. And the one isotope, chlorine 36, with an odd number of neutrons, is radioactive. It is only in traces and has a half-life of 301,000 years. This is a picture of table salt crystals, NaCl, sodium chloride, and that's the main source for chlorine. This is a picture of Salt Island in Cape Verde. Here are two examples of chlorine minerals. At the left, it's sylvite, also called sylvine. It's potassium chloride. And at the right, that's carnallite, potassium magnesium chloride, hexahydrate. This is a picture of the periodic table. Chlorine is located at the top right corner, and it comes from exploding massive stars and white dwarfs. It's a member of the group of the halogens. Halogen means a salt maker. That's the seventh group in a periodic table. And chlorine is an essential element for life. This is a diagram of the abundance in Earth's crust of the chemical elements. And you can see chlorine is here. It's number 2 in abundance among the halogens. Number 1 is fluorine. Bromine is here. Iodine is here. So chlorine is about the same as lithium. This is a diagram of the electronegativity of the chemical elements, and chlorine is at number 3. There are only two elements with higher electronegativity, that's oxygen and fluorine. It has a electronegativity of 3.2 on the Pauling scale, and that makes it very reactive. The gentleman at the left, that's Carl Wilhelm Scheele. He was the first person who isolated chlorine in 1774 by a reaction with hydrogen chloride with manganese dioxide, which gives you manganese chloride, water, and chlorine gas. But he was not able to recognize chlorine as an element, and that's what the gentleman at the right did. That's Humphrey Davy. He was the first person who recognized chlorine as a chemical element in 1810. This is the chloralkali process. That's how you make chlorine gas. It is produced in a membrane cell by electrolysis of sodium chloride. In Germany it's called natrium chloride. And one important piece is this semi-permeable membrane that's made of naphthalene. It's here. And this membrane blocks the chloride and the hydroxide ions. And the products are chlorine gas, hydrogen, and sodium hydroxide. The world production of chlorine in 2021 was 92.3 million metric tons, with a worth of 35.7 billion US dollars. This is another method. It's called Downs process. It was patented in 1924 by American chemist James Cloyd Downs. It's an electrolysis of molten sodium chloride, and calcium chloride is added to the sodium chloride to lower the melting point as a flux. And the products of this reaction are sodium metal and chlorine gas. Chlorine was used for bleaching of paper until it was replaced by hydrogen peroxide, H2O2. This is a picture of water chlorination with sodium hypochlorite NaOCl. Chlorine is used in the swimming pool. Typical concentration is 1 to 3 parts per million. But this smell in the swimming pool comes not from chlorine gas, but from the compound NH2Cl, that's chloramine. This is another important compound in chlorine chemistry, that's hydrogen chloride, HCl. 38% aqueous solution is called concentrated hydrochloric acid, and gastric acid is hydrochloric acid with lower concentration. The human body produces about 1.5 liters a day, and typical pH in gastric acid is 1 to 3, so that's quite strong acid. And this acid is able to split proteins and to kill bacteria. And this only works because there's a lifelong regeneration of the stomach cells in the human body. Later, the hydrogen chloride is neutralized in the duodenum by sodium hydrogen carbonate, which gives you sodium chloride and carbonic acid. These are two examples of applications for HCl, hydrochloric acid. At the left, that's for the regeneration of ion exchanges. The sodium and calcium ions are replaced by protons, and then the ion exchanger is ready for another use. At the left, that's a picture of steel. Hydrochloric acid is used for pickling of steel. That's cleaning the surface of steel by acid. And typical concentration for this procedure is 18% HCl in water. Another compound, it's hypochlorous acid, HOCl. It was discovered by Antoine Jérôme Ballard in 1834. HOCl is used in the white blood cells as a weapon against intruders. You can use this compound also for wound care as a disinfectant and for organic synthesis. And the reaction that leads to hypochlorous acid, it's a disproportionation of chlorine. Chlorine plus water gives you hypochlorous acid plus hydrochloric acid. Disproportionation means atoms from the same element go from a common oxidation state. Some go higher, some go lower. So the chlorine has oxidation state 0. Hypochlorous acid, oxygen has a higher electronegativity, so chlorine has +1 here, and in hydrochloric acid, -1. Another compound is perchloric acid, HClO4. It's oxidizing at a superacid. This is a picture from Phoenix Marslander. Martian soil contains half to 1% toxic perchlorate, ClO4-. So this means if you one day want to do agriculture in Mars, you have to first treat the soil. For example, you can rinse off the perchlorate or use a reducing compound to get rid of the perchlorate. At the right, you can see the structure of sodium chloride, NaCl. Green is the chloride ions, and in purple, that's the sodium ions. At the left, that's a picture from a mine in Merkers in Germany. The world salt production in 2021 was 290 million tons. Seawater contains about 3.5% sodium chloride. And NaCl can be used for table salt, for food preservation, and as a road salt. If you want to test a substance for chloride, this is how you do it with silver nitrate. If your mixture contains chloride, then you will get a white precipitate of silver chloride, which is very stable because it has a high lattice energy. So the silver and the chloride ions fit nicely together, build a stable structure. So this is the chemical reaction. Sodium chloride plus silver nitrate gives you silver chloride precipitate plus sodium nitrate. And with bromide ions, you get a pale yellow precipitate, and with iodine ions, you get a bright yellow precipitate. is a compound ammonium chloride, NH4Cl. It is in nature as a mineral. It's called sal ammoniac or salmiac. And ammonium chloride is also one of the products of the Solvay process. That's the reaction of carbon dioxide with ammonia and sodium chloride and water, which gives you ammonium chloride and sodium carbonate. And ammonium chloride is used as a nitrogen source in fertilizers. This chlorine dioxide, ClO2, it is used for bleaching, water treatment, and disinfection. At the left, that's a picture of ClO2 in water. And it can be produced by a reduction of sodium chloride with sulfur dioxide and sulfuric acid. This gives you ClO2, chlorine dioxide, plus sodium hydrogen sulfate. So the chlorine has here state +5 and here +4. That's why it's a reduction. There's another compound, Chloroform trichloromethane, CHCl3. It is a natural product. It is produced, for example, by seaweed and fungi. It is used as a solvent, refrigerant, and as anesthetic. Chloroform is a product of the radical halogenation of methane with chlorine. That gives you chloroform plus 3 hydrogen chloride. But in this reaction, there's a mixture of products, for example, dichloromethane, monochloromethane. So you need extra step, that's the distillation of the products. And this can be done easily because these different products have a very different molecular mass and different boiling points. This is one of the products, chloromethane, CH3Cl. It is the former refrigerant R40. It is another natural product of phytoplankton. And this compound was detected by the ALMA telescope. ALMA, that's Atacama Large Millimeter Array Telescope in Chile, around infant stars in IRAS 16293-2422. This compound is important because it is used for the synthesis of silicon. And this is how you do it. At the right, that's the intermediate product, that's dichlorodimethylsilane. And at the left, that's the structure of silicone. This reaction is called Müller-Rochow process or direct process. It was invented in 1941. First step is reaction of chloromethane with silicon. Gives you again a mixture of several chlorinated products. And again, this chlorine atom has a high mass, so this products can be separated by distillation. And the hydrolysis of dichlorodimethylsilane gives you silicone and byproduct hydrogen chloride. This is the polyvinyl chloride PVC. At the bottom, this is the structure. It's like polyethylene, but with one chlorine atom instead of hydrogen at monomer. PVC was discovered in 1872 by Eugen Baumann. The world production is 40 million tons per year. It is a very resistant material. That's why it can be used, for example, for pipes and cables. And the monomer is made by thermal decomposition of 1,2-dichloroethane. Gives you hydrogen chloride plus vinyl chloride, and the polymerization gives you PVC. This important compound from the pharmaceutical chemistry, it's Chloroquine. It was discovered by Hans Andersag in 1934. It is an anti-malaria drug and can also be used for rheumatic and liver diseases. And this compound has made it into the World Health Organization's list of essential medicines. At the left, this is the structure of DDT, that's para-para diphenyl trichloroethane, a nerve poison with a long half-life. And you can see aromatic benzene ring. This position opposite is called para. If the chlorine atom were here, this then would be meta, and here it would be auto. And This compound was discovered in 1874 by Ottmar Zeidler, and later it was recognized as an insecticide by Paul Hermann Müller in 1939. He also got the Nobel Prize in Medicine in 1948. DDT was in high use for several decades, from the 50s to the 80s. In 1972, there was a ban in the USA, and that caused a comeback of the bald eagle. The problem with DDT is its long half-life, not only of this compound, but also of its reaction products. And species at the top of the food chain are highly endangered because in the food chain these compounds accumulate. And that's why the comeback of the bald eagle is very good news. And that was today's video about the chemical element chlorine. Thank you for watching. Have a nice day. Bye-bye.